To feel the texture of time, first we must slow it down. Turn your mind away from the sharp, bright, and noisy lights of the present. Leave behind the blue glow of digital screens, the persistent rhythm of notification sounds, the never-ending hum of the modern city. Bring before your eyes a photograph in sepia tones, its edges slightly faded. The year is 1927. The season is about to turn into the Southern Hemisphere's unique, heavy, and humid autumn. The place, Australia, the city of Brisbane, the newly constructed campus of the University of Queensland. The air is hot, but this is not a scorching, dry desert heat. This is a heat that covers a person, like an invisible blanket, slowing down movements, deepening the breath, a humid and dense heat coming from the ocean. This weight, brought by the tropical climate, it is as if it has permeated time itself. Here, hours do not move by the ticking of a clock, but by the speed at which beads of sweat and trickle down a forehead. The stone walls of the university, having soaked up the sun's heat all day long, are now, with the approach of late afternoon, slowly, gently, giving that heat back to the corridors. In the shadow of the sandstone buildings, silence has almost turned into a tangible substance. Every footstep, echoing in the halls, vibrates the dust motes suspended in the void. Imagine those dust motes dancing within the horizontal beams of golden sunlight, filtering through the high arched windows. Millions of tiny particles. They are in no rush. They do not resist gravity, but they do not surrender to it immediately either. They float, they swirl, they descend slowly. The air in this laboratory is different from the outside world, denser, more expectant, more patient. The year 1927 for the big world outside is actually the year of speed. In the Northern Hemisphere, in America and Europe, the roaring 20s are alive. The syncopated rhythms of jazz fill the dance halls. Automobiles are getting faster. Airplanes are trying to cross oceans. Telegraph wires tremble with news, circling the globe in seconds. Humanity is under the spell of mechanization, speed, and noise. Everything wants to be faster, higher, stronger. However, in Professor Thomas Parnell's laboratory, there is no trace of this global rush. This place is like a sanctuary built outside of time. Glass bottles standing on shelves, brass scale weights, the smell of varnish on wooden tables. Everything carries the peace of a deep sleep. Professor Parnell stands at his desk, wearing a linen jacket, a light layer of sweat on his forehead. He, in this age of speed, is a man who has chosen to focus on the slowest thing in the world. He is looking at the substance in front of him. Pitch. This substance, at first glance, is as black as coal, as hard and shiny as obsidian stone. It does not swallow light, it reflects it sharply back. If you were to take a hammer and strike it, it would shatter into thousands of pieces with a clink, just like a piece of glass. Its edges are sharp, it is solid, it is cold. Every rule of logic in the world says that it is a stone, but Professor Parnell knows beyond the visible face of matter. He knows its deep, dark dream. This black mass actually hides a memory dating back millions of years. This pitch, once, before humanity even existed, was part of forests formed by giant ferns and massive trees. In the swamps of the Carboniferous period, they were leaves drinking sunlight, trunks falling to the soil for hundreds of millions of years, deep within the earth, under immense pressure and heat. Till it cooked. It was crushed. It was compressed. It transformed. The green life of those old forests evolved underground into a black, dense, viscous energy. It became the heaviest, laziest, most movement-averse sibling of oil. Now, in the year 1927, while sitting on a laboratory table, it is asked to wake from that sleep of millions of years, but it does not want to wake up. It wants to stop. It wants to stay where it is, to lock its molecules tightly together. Professor Parnell prepares this stubborn substance. A heat source is lit. A faint scent spreads through the laboratory, burnt, earthy, and chemical. The heated pitch begins to slowly relax. It sets aside its solid shell, that deceptive armor. It turns into a pitch-black, dense, syrupy liquid. But this fluidity does not resemble the cheerful flow of water. This does not even resemble the lazy flow of honey. This is like molten rock, like the cooling, final state of a lava river. The professor prepares the glass funnel in his hand. The funnel is transparent, fragile, and ready to wait. Parnell begins to pour the molten pitch into the funnel. Even this pouring moment is a meditation. The black liquid stretches as if it does not want to leave the container, flows into the funnel in a thick, shiny ribbon. When it hits the wall of the funnel, it makes no sound. It just spreads silently, clogs the throat of the funnel, fills it, settles. When the process is done, the funnel is filled to the brim with that black darkness. Parnell covers the top of the funnel, places it under a bell jar in a safe corner, and the greatest action in the laboratory begins. Waiting. Under the bell jar, the pitch is now trying to get used to its new home. It has to accept the shape it took when hot, As it cools, the molecules slow down. Their vibrations decrease. They hold onto each other tightly again. "Don't let me go," whispers one carbon atom to another. "Let's stay here. Let's not move. Outside is too fast. Outside is too tiring." This process of cooling and settling does not take an hour, does not take a day, does not take a week. Professor Parnell knows the time he must wait for the pitch to fully settle in the funnel, for the air bubbles inside to surface and vanish, and for the matter to become completely ready. If rushed, the experiment is ruined. If rushed, nature takes offense. Exactly 3 years, from 1927 to 1930. This is just the time for the pitch to cool and settle. Seasons pass through the laboratory window during these 3 years. Rains fall. Queensland's famous downpours beat against the glass. The sun comes out, melts the asphalt. Winds blow, carrying the scent of eucalyptus trees inside. Students come, graduate, go. The world economy is shaken by the Great Depression of 1929. Stock markets crash. People's lives turn upside down. Fortunes are lost. Hopes are destroyed. New hopes are born. But inside that glass bell jar, in the corner, time has stopped. The pitch is not interested in the economic crisis outside, not interested in people's rush, their fears, their ambitions. It just cools, it just settles, it just tries to find its own internal balance. Listen to the silence under that bell jar. There is the self-talk of matter. There is the preparation of billions of molecules giving a silent war against gravity and eventually surrendering to it. This is like a monk retreating to a cave. This is like a seed waiting to crack under the soil. Professor Parnell occasionally comes and looks at the jar. He does not touch. He does not move it. He just looks. There is respect in his eyes, because the thing in front of him represents a patience that exceeds a human lifespan. Parnell perhaps feels his own mortality while looking at that black mirror. He himself is aging. His hair is greying. His skin is wrinkling. But the pitch stands in the same smoothness, the same blackness, the same youth, and the same old age. The time passed from that hot afternoon of 1927 to that fateful moment in 1930 is actually an inhalation, a long, deep breath lasting 3 years. The lungs fill with air, the rib cage expands, and everything prepares for that inevitable moment of exhalation. Until the moment the tip of the funnel is cut, the flow begins, gravity declares its victory. The pitch gathers its strength in the silence. And we too, now in the dim light of that laboratory, accompanied by the dance of dust motes, feel the weight of this preparation upon us. We are in no rush. Where are we catching up to? Time is flowing away anyway, whether we run or stand still. So let us stand and add our own sleep to the black, deep sleep of the pitch. Our way of perceiving the world is largely based on the simple lies whispered to us by our sense of touch. We touch something. If it shows resistance under our finger, we call it solid. If it slips through our fingers, we call it liquid. Tables are solid. Tea is liquid. Rocks are solid. Rivers are liquid. Our mind needs these sharp distinctions to feel safe. We want to know that the ground we step on isn't flowing away at any moment. We want to believe the wall we lean on will support us forever. However, the black mass standing under that bell jar at the University of Queensland, the pitch, tells us that nature does not fit into such simple categories. It slaps us in the face with the fact that these distinctions are human fabrications. Pitch is like a shaman carrying the dual nature of matter. It is both stone and water. It both stops and goes. It is both there and has already set off. To understand this paradox, imagine approaching the cold, black surface of the pitch once more, but this time not with the curiosity of a physicist, but with the sensitivity of a sculptor. If you entered the lab, lifted the bell jar, took a heavy steel hammer in your hand, and struck that black mass with all your might, what would happen? Your expectation would be for the hammer to sink into it, as if you hit a soft substance, like Play-Doh, right? After all, it is a fluid substance. But no, the moment the hammer hit the pitch, a sharp cracking sound would be heard, grating on the ears. The pitch would not absorb the hammer's blow. It would resist. And in the face of this sudden, violent energy, just like a crystal vase, just like hard glass, it would shatter into shrapnel. Black, sharp-edged pieces would scatter on the laboratory floor. Each piece would refract the light. If you picked one up, you could cut your finger. If you struck these pieces together, a dull sound, like rocks hitting each other, would emerge. This is the solid face of pitch. Under sudden stress, against fast blows, it is an uncompromising rock. Because its molecules do not have the time to react to that sudden energy, to change places, to stretch. Time has not been given to them, and where there is no time, there is no flexibility, only breaking. However, if you put that hammer aside and place just a feather-light weight on the pitch and wait, that is when the dream of the matter changes. That hard, brittle, glass-like substance takes on a completely different identity with the soft touch of time. It takes off its solid armor. It releases that hidden river inside. It begins to slowly take in that light weight you placed upon it. It swallows it. It wraps around it, and accepting the gentle invitation of gravity, it begins to flow downwards. The name of this miracle is viscosity. Viscosity is the internal resistance a fluid shows against flowing. It is its mood, its character, its level of stubbornness. Think of the viscosity of water. Water molecules are like cheerful and hyperactive children. They don't hold on to each other much. They pass by one another. They slide. They separate. When you spill a glass, the water molecules say goodbye and scatter in a second. They are free, but they are also bondless. Think of honey. Honey molecules are a bit more emotional. They like holding on to each other. While flowing from the spoon, they form those long, golden threads. Don't leave me, they say. But gravity still wins, and they flow. Now, think of the pitch. The pitch is molecules. That is, those long hydrocarbon chains are madly in love with each other. Or perhaps they are tied together with knots too complex to untie. Imagine how a headphone cable gets tangled in your pocket. Now imagine billions of headphone cables tangled together like a giant ball of yarn. For pitch to flow means this massive microscopic knot ball must untangle. For one molecule to move, 10 other molecules around it must give way. But those 10 molecules are held by 100 other molecules. Everyone wants to move, but everyone is tied to each other. That is why the viscosity of pitch is exactly 230 billion times greater than the viscosity of water. Try to visualize this number in your mind. 230 billion. This is like comparing the speed of a turtle to the speed of light. This is like comparing a human lifespan to the age of the universe. This enormous internal friction is the answer to why pitch looks solid. It flows so slowly that, within the time frame we perceive as humans, its movement is like zero. We look at it and say it's stopping. It looks at us, if it could look, and would say, "You are too fast. You just vibrate and vanish. I am dancing to the rhythm of eternity." This dual nature whispers to us that everything in the universe is actually in a state of flow. The chair you sit on, the building you live in, the pavement stones you walk on, the distant mountains, none of them are truly solid. They are all rivers, flowing on different time scales. Glass flows. If you look carefully at the windows of very old cathedrals, you will see that the bottoms are slightly thicker than the tops. Over centuries, glass has bowed to gravity and glided downwards at a microscopic speed. Glass is a supercooled liquid, a frozen waterfall. Mountains flow, they rise. With the push of tectonic plates, they lower with the erosion of wind and water. If you watched a video of millions of years sped up, you would see mountains rising and falling like ocean waves, continents drifting from here to there like bumper cars. Solidity is an illusion. Solidity is just a result of our impatience. The pitch drop experiment is the laboratory scale proof of this great truth. It reminds us that matter has a memory. The pitch remembers the moment it was first put into the funnel, remembers the moment it was heated. And now, being faithful to those moments, it does what its nature requires. It doesn't rush, it doesn't break. If you don't force it, it just performs the most basic action of existence, reaching equilibrium. Deep inside that black substance, molecules are slowly, one by one, sliding over each other. This is a silent dance, a waltz without music. From the outside, absolute stillness is seen, but inside, at the atomic level, the universe's most patient journey continues. On that fine line between solid and liquid, between stopping and going, between being and nothingness, the pitch stands there and waits, not for us to understand it, just because its own time has come. The laboratory door was closed, lights were turned off, and that hot day of 1927 gave way to a cool evening, then to the night. The pitch poured inside the funnel was now in a new and strange universe. Until a few hours ago, it was heated, forced. Its form was distorted. Now it was cooling, solidifying, and becoming silent. But this silence was not a dead silence. This was the silence of deep preparation before a great journey. Professor Parnell had covered the funnel with a glass bell jar. This jar was not just a cover protecting it from dust, but also a transparent wall keeping time outside. Inside the jar, there was no longer wind, no seasons, no breath of people. Only the pitch and its patience existed for the next 3 years. That is, for exactly 1,095 days. To understand what happened under this jar, we must lower our gaze to a microscopic level. Looking from the outside, nothing was happening. A pitch black surface, motionless, dull. But inside, there was feverish, settling work. The pitch was trying to accept the shape of the funnel. Think of the air bubbles formed when it was poured hot. Small, invisible air pockets trapped in the depths of the pitch. These bubbles wanted to be free, wanted to surface and burst, to mix with the air. In water, an air bubble surfaces in 1/10 of a second. It goes bloop and vanishes. In honey, an air bubble surfacing takes a few minutes, maybe an hour. It is pleasant to watch. It rises slowly, waits at the top, and then bursts. But for an air bubble inside the pitch to surface is a climb lasting months. In late 1927, a microscopic speck of air trapped in the depths of the pitch made its first move upwards. It had to push the dense, sticky wall of molecules in front of it. Every micron of ascent required immense effort. Entering the year of 1928, that bubble was only halfway there. In 1929, it approached the surface, and perhaps only in 1930 did it vanish by creating a tiny crater, impossible to see with the naked eye, on the surface. This was the settling process. The pitch was purifying itself of the excesses inside, the voids, the unrest. It was making itself a pure, smooth, single piece of mass, leaning against the glass walls of the funnel, learning its curves, arranging its molecules according to those curves. Meanwhile, outside the bell jar, one of the loudest, most chaotic periods of human history was taking place. In the year 1928, in another corner of the world, Alexander Fleming noticed mold fungus in a petri dish in his laboratory. By chance, penicillin was found. The medical world sped up. Human life began to extend. Everything happened in an instant. A moment of carelessness. A moment of discovery. The same year, Amelia Earhart became the first female passenger to cross the Atlantic Ocean by plane. Speed, altitude, engine noise, gliding above the clouds. Humanity was defying gravity. But the pitch was not defying gravity. It was falling in love with gravity. Then 1929 came. October, Black Thursday, the New York Stock Exchange crashed. Panic on Wall Street. People shouting, running around, trying to sell the pieces of paper in their hands. Telephones didn't stop. Telegraph wires burned. In one day, fortunes evaporated. Suicides, bankruptcies, screams. The world financial system shattered into pieces, just like broken glass. Because the system was too tense, too swollen, too fast. It had no time to stretch, and it broke. In the laboratory in Queensland, however, the pitch was completely unaware of this global scream. That day, the stock markets crashed. The pitch perhaps slid down a nanometer, just that much. Its economy was different. Its currency was not movement, but stillness. While the world outside burned, it preserved its own existential peace inside the cool glass. Perhaps this was the first lesson the pitch taught us. Even while the apocalypse breaks out outside, if you can stay in your own center, inside your own bell jar, peace is not disturbed. Professor Parnell waited patiently for these 3 years. Who knows how many times he entered the lab and looked at that funnel. How many times he took the scissors in his hand, wanted to cut the tip of the funnel to start the flow. He wondered, is it ready? Isn't 1 year enough? 2 years? This was the patience of a gardener. A gardener who plants a seed in the soil and doesn't dig it up every day to check if it has grown. He knew that forcing the process is killing the result. If he had cut the funnel tip early, the pitch would not have found its internal balance yet. The flow would be irregular. The tensions inside would distort the shape of the drop. So he waited. When the year 1930 arrived, the world was no longer the world friend of 1927. The Great Depression had enveloped everywhere. Armies of unemployed wandered the streets. Despair was dominant. But inside the laboratory, the object standing on that table in the corner was now ready. The 3-year incubation period was over. The pitch had integrated with the funnel. It had cooled, calmed down, accepted. It was no longer just a mass. It was now a candidate to become a flow. These 3 years were a sort of breath-holding exercise. Now, the time had come to exhale that breath. This was the maturation of silence. Just like wine waiting in a barrel, just like a baby waiting in the mother's womb. Doing nothing is sometimes the greatest action. The pitch did nothing for 3 years, and thanks to this, prepared for a journey that would last a century. Imagine the 3 years of dust accumulating on the glass of the bell jar, a thin grey layer, physical proof of time. Inside that black, shiny, wet-looking darkness was waiting for the first movement order. And the order would come not with a voice, but with the stroke of scissors. Silence was about to be broken, or rather, silence was about to change shape. From a stagnant silence to a flowing silence, the transition would begin. The year 1930, Professor Parnell took sharp scissors in his hand, exhaled a deep breath. After a wait lasting 3 years, he cut the seal, keeping the bottom tip of the funnel closed. This action looked like a simple, surgical intervention from the outside. Snip. A small piece fell. The tip of the funnel opened. The pitch was now left alone with gravity, with that inevitable lover. The obstacle between them was removed. Normally, what do you expect? When you turn on a faucet, you expect water to flow. When you pierce a bag, you expect sand to pour out. But when Parnell opened the funnel, nothing happened. At least, nothing happened for the human eye. The pitch stood just as it was the moment it was cut, black, shiny, and stubborn, as if defying gravity, saying, "You cannot pull me." It is exactly at this point science and philosophy unite under the roof of a fascinating concept. In physics, in fluid mechanics, there is a very special, almost poetic number. It is called the Deborah Number. The origin of this name does not come from laboratories, but from a much older sacred text. In the book of Judges, in the Torah, there is a song sung by the prophetess Deborah. The mountains flowed before the Lord. Stop for a moment and visualize this sentence in your mind. The flowing of mountains, those massive, unshakable mountains we know as hard as rock, flowing away like a river, like a wave. Is this possible? Science says yes, only if you wait long enough. The Deborah number is a simple ratio, the ratio of a substance's time of relaxation to our time of observation. This formula reveals the universe's greatest secret. There is no sharp distinction between solid and liquid. Everything depends on how long you look at it. To understand this concept, let's stretch our perception of time. Why is water liquid? Because water molecules adjusting to a new shape takes a trillionth of a second. Our observation time is a tenth of a second. Our observation time is much longer than water's relaxation time. That is why we see water flow. What about mountains? A mountain's relaxation time is millions of years. Our life is at most 80 or 90 years. Our time is so short beside the mountain's time that the mountain appears frozen to us. Whereas, if you looked with a divine eye, that is, an eye seeing millions of years as 1 second, you would see the Himalayas rising and falling like an ocean wave, continents crashing into each other like bumper cars and changing shape, rocks being kneaded like dough. Everything flows. Stones flow, metals flow, glass flows, and pitch. Pitch is a purgatory stuck between human time and geological time. Its Deborah number is at the limit of our perception. If you look at it for a second, it is a stone. If you look at it for a lifetime, it is a liquid. The pitch drop experiment is more than a patience test for this reason. It is a mirror reminding us of our own transience. When we think the pitch is not flowing, actually, the one mistaken isn't the pitch, it is us. We are too fast. Our hearts beat too fast. Our neurons fire too fast. Our perception of now is too narrow. The pitch whispers to us, you are just sparks. You flash and fade. I am living of the process. In 1930, when the funnel tip was cut, a race did not actually begin, because a race requires speed. What began here was a surrender. The air inside the bell jar was still. Dust motes were settling slowly, and the pitch's molecules toward that cut tip set off with steps too small for us to see. One molecule let go of its neighbor's hand, another slid a little further down, a chain stretched, a bond loosened. This was not like ice melting, it was like a glacier walking into the ocean. Parnell, while setting up this experiment, was actually asking this: if we free the world from human-centric time perception, what remains? What remains is pure flow, silent, non-judgmental, unhurried, unstoppable flow. We usually see time as something spent, lost, or gained. We say, I have no time. We say, time doesn't pass. But the Deborah Number teaches us that time is not a possession, it is a perspective. Right now, as you read these lines, do you think the room you sit in is standing still? No, the Earth is rotating, flying around the Sunday. The solar system is drifting within the galaxy. The galaxy is drifting within the universe. And within all this cosmic speed, matter itself is slowly decaying, changing, flowing. The walls of your house are collapsing very slowly. The papers of the books on your shelf are very slowly yellowing and turning to dust. Your bones are very slowly changing density. We just call a very small cross-section of this flow life. The pitch drop is a hammer breaking this illusion. Inside that glass bell jar, it shows us this. Look, even the thing you think is most motionless is going. Why are you trying to hold on? After 1930, days turned into weeks, weeks into months. At the tip of the pitch, a vague bulge began to form. A drop was taking shape. But this was not like the falling of a teardrop. This was like a statue, slowly changing form. Time was stretching inside the laboratory. While clocks outside ticked tick-tock, time inside was stretching like gum. And we are invited to relax within this stretching time, like Deborah's mountains, like the glass of cathedrals, like Parnell's pitch. Just flow. Don't try to be solid. Don't try to stand strong. Let gravity, that is, life, take you where you need to go in its own time. Your viscosity might be high. Moving might be difficult. Your internal resistances, fears, habits might be holding you back. But remember, everything flows only if you wait long enough. And now, to witness the pitch's first great journey, that epic fall of the first drop, we will turn the calendar pages a little faster, but never forgetting the speed of the pitch. When the funnel tip was cut in 1930, time split into two branches like an invisible river. The first branch was the time of the outside world. This river was foaming, overflowing, crashing into rocks, and destroying everything in its path. Human history was drifting towards disaster with unprecedented speed. Newspaper headlines shouted with larger fonts every day. Radios spewed anger with crackling voices. The second branch was the time inside the bell jar in Professor Parnell's laboratory. This river was like a stagnant lake. Its surface didn't even ripple, only deep down, very deep. There was an invisible current from 1930 to 1938. During those 8 years, a black teardrop budded at the tip of the funnel. What was happening outside? The footsteps of fascism in Europe were echoing in concrete squares. Civil war in Spain had turned into a tragedy where brother shot brother. In the Far East, Japan was invading China. Factories were no longer producing toys or cars, but tanks and rifles. The sky was darkening with the shadows of zeppelins and bombers. Humanity was stoking a fire that could bring its own end. The nucleus of the atom was about to be split. Einstein was writing his famous letter to Roosevelt. "Be careful," he said. "A great power could be unleashed. Energy, explosion, speed, destruction." And right at this time, in December of the year of 1938, at the University of Queensland, in that quiet room, the black drop at the tip of the funnel could no longer resist the gentle persistence of gravity. The neck of that drop had thinned over the years, reduced to the thickness of a hair strand. Molecules were using their last strength to hold onto the main mass above. But below was much more peaceful. The earth was calling. December 1938, summer heat in Australia. Sound of cicadas seeping in through the laboratory windows. Maybe a late afternoon, maybe midnight. No one was there. Professor Parnell, maybe drinking his tea at home, maybe listening to gloomy news from Europe on the radio. And plop, at the end of an 8-year pregnancy, the first drop fell. The sound of this fall was quieter than a needle dropping to the floor. That black, shiny, perfect sphere floated in the air, embraced gravity, and hit the floor of the beaker below, while the world outside went to war. Inside, a drop settled into its place in peace. This contrast is chilling. 1939, 40, 41. The world was in flames. Warsaw was being bombed. London was burning under the Blitz. Ships were sinking at Pearl Harbor. On the icy steppes of Stalingrad, millions of people were dying, freezing, starving, or by bullets. They were the bloodiest, loudest, cruelest years of human history. Millions of lives snuffed out in an instant. Cities wiped off the map. But inside that bell jar, the second drop had already begun to form slowly in the midst of this chaos. The pitch didn't care about Hitler. The pitch didn't hear Churchill's speeches. The pitch didn't feel the pain in concentration camps. This was the frightening neutrality of nature. Laws of physics show no mercy, no hatred. They just work. While bombs destroyed buildings outside, the pitch's molecules were sliding a millionth of a millimeter. While people ran to shelters outside, the pitch was flowing only towards gravity, with that infinite serenity. In this indifference, there is actually a strange consolation. It whispers to us that even the greatest pains, the greatest disasters in the world are temporary. You fight, says the pitch. You shout. You destroy. I am here. I continue to flow. And when you all become dust, I will still be flowing. The war ended. 1945. Atomic bombs were dropped on Hiroshima and Nagasaki. Humanity released the energy inside matter in its most destructive form, a speed that vaporized cities in a second. The pitch, however, continued to use its energy in its slowest form. February of the year 1947 arrived. The world was licking its wounds. The United Nations had been established. The icy breath of the Cold War began to be felt, and in the laboratory, again at a moment when no one was there, the second drop fell. It had taken 9 years. This time, a child born of the year the war started had now finished a primary school. The second drop fell onto the first drop. 2 black masses met, slowly mixed into each other. The first drop carried the memory of 1938. The second drop, the burden of all those dark years of the war. Now, they were fusing silently. The past was integrating with the present. Did Professor Parnell see this fall? No. Again, no one saw the moment of the fall. But he noticed it had fallen. He saw that black mass rising in the beaker. The professor was old now. That young, excited man, sweating in the lab with his jacket off in 1927, was now tired. His hair had whitened. His steps had slowed. Perhaps his own viscosity had increased. Had Parnell realized that this experiment he set up would last longer than his own life? Probably, yes. On September 1st, 1948, Professor Thomas Parnell closed his eyes to life. The experiment was left fatherless. The pitch did not greet its creator's death by mourning. It didn't stop, didn't slow down, didn't speed up. It just continued to flow. This is the greatest legacy a creator can leave to their work. A system that does not need them. Parnell was gone, but the pitch was there in that dusty corner in the corridor. The third drop had already begun to gather at the tip of the funnel. 1950s, the rock and roll era was beginning. Elvis Presley on radios, television entering homes. People's attention was now even more scattered. Colourful screens, fast cars, consumer culture. That corner of the laboratory became an increasingly forgotten place, like an old piece of furniture. That strange black thing there, no one looked at it, but it continued to keep time for everyone. The third drop fell in the year 1954. The Korean War was over. The structure of DNA had been discovered. Humanity had decoded the code of life. The pitch, however, was repeating the simplest code of matter: reach equilibrium. These years are actually the lost years of the pitch. There are very few records, very little interest. It is like a dervish, talking to itself in the dark. But in this silent period, as drops accumulated, a black mound began to form in the beaker below. Every falling drop piled onto the previous one, then slowly spread. But the pitch in front of him stood with the same indifference. While Mainstone aged, the pitch only matured. By the end of the 1960s, Mainstone was now looking at the bell jar as the first thing every morning when entering the lab. Is it today? The pitch gave no answer. Only black, shiny silence. Sometimes, when left alone in the lab, late at night, we can imagine Mainstone talking to the pitch. "Why don't you fall?" he would whisper. "Perhaps. Are you testing me? Are you measuring my patience? Or are you shy when I look?" This resembled that absurd, that cyclical waiting in Samuel Beckett's play. Waiting for Godot. Godot never came, but Vladimir and Estragon continued to wait, because waiting gave them a purpose. For Mainstone, too, the pitch had become a purpose. He was the keeper of the modern age's slowest clock. August 1970. It had been a year since humanity set foot on the moon. Technology had peaked, and the fifth drop fell. Mainstone was not there again. He had waited 8 years, more than 2,900 days. And in that critical second, in that plop moment, life had intervened. Maybe he was teaching a class. Maybe he was sleeping. Maybe he just turned his back. These missed moments began to open a strange wound in Mainstone's soul. This was turning into an obsession. The next one, he said to himself, I will definitely see the next one. No escape. 1970s. Past. Disco music. Oil crisis. Political turbulence. Mainstone was now a middle-aged man. He had advanced in his career, but in front of the pitch, he was still like an apprentice. The sixth drop was preparing. As the pitch's neck elongated, Mainstone's patience thinned. In this process, Mainstone turned from a scientist into a lighthouse keeper. In the middle of the ocean, alone, a keeper watching, not the storm, but the stillness. The observer's ordeal is this: to be taken captive by the thing observed. In quantum physics, there is something called the observer effect. Observing a particle changes its behavior. But here, the situation was exactly the opposite. The pitch wasn't changing. The pitch was changing the observer. Mainstone, learn to slow down. Learn to be patient. Learn to make peace with disappointment. That black drop was silently whispering to him, My time is not your time, John. You have to abide by my calendar. I cannot abide by yours. This was the most elegant declaration of human helplessness against nature. We think, we control nature, we change the direction of rivers, we pierce mountains, we split the atom. But with gravity, with that simple, that fundamental force, we cannot negotiate. A drop falls when it wants to fall, whether the professor is in class, or asleep, or on vacation. Mainstone, at the end of the 1970s, was looking at the bell jar with the wisdom of a man, resigned to his fate. Pitch and man had become two companions of destiny, bound to each other, one fluid but slow, the other solid but aging. And in front of them stood the years 1979 and 1988, which would turn into a tragic comic story. Years when the universe's sense of humour would mock a scientist's patience in the most brutal way. 1979, April, the soft yellow light of autumn in Brisbane was hitting the campus. Mainstone was experienced now. He had memorized the drop's behaviors. That black, pear-shaped mass at the tip of the funnel was about to surrender to gravity. Its neck had thinned, become a thread. Any moment now, said Mainstone. This weekday, during working hours, we will see it, together with the students. But the pitch's calendar did not recognize that artificial concept of week invented by humanity. For the pitch, there was no difference between Monday and Sunday. No holiday, no shift. One Friday evening, while leaving the lab, Mainstone looked at the pitch for the last time. See you Monday, he said. Wait for me. Maybe the pitch answered. with a millimetric movement at that moment. But Mainstone didn't see it. The weekend passed. Saturday, campus empty. Sunday, campus silent. Bird sounds, wind sound, and inside the laboratory, that inevitable moment, Sunday, in that sacred moment of loneliness when no one was there, no one witnessed, the sixth drop let itself into the void. When Mainstone opened the laboratory door Monday morning, his heart nearly stopped. Inside the bell jar, there was a fresh, shiny blackness on the ground. The tip of the funnel was empty. It had fallen. That weekend, that silent Sunday, the pitch had played its special show to empty seats. Imagine the feeling of emptiness Mainstone felt at that moment. A disappointment, yes, but also a strange respect. It didn't wait for me, he thought. It didn't care about my interest in it, my professorship title, my years. This was the declaration of nature's sovereignty. But the real tragedy, the real great irony, would happen 9 years later, in 1988. This date was important for Queensland. There was the Expo 88 fair in the city. The world was flowing to Brisbane. Technology, future, innovation was being discussed. In that corner of the laboratory, the seventh drop was preparing. This time, Mainstone was determined. Never, he said. I will never miss it. Not this time. The pitch, his neck, had thinned so much that it stood like a wire, only reflecting light. Gravity was pulling the drop down. Molecules were screaming. Mainstone was on guard. He wasn't leaving the lab. His eyes were bloodshot. He was tired. But that moment, he wanted to see that moment of rupture live. This would not be scientific data for him, but a spiritual completion. July, a hot day. Hours were passing. The drop wasn't falling. Mainstone shifted in the chair. His throat was dry. His stomach was rumbling. Just a tea, he said to himself. I'll just grab a cup of tea and come back. The cafeteria is right there. Takes 5 minutes. The thing that hasn't fallen for 9 years isn't going to fall while I get tea, right? This is physically impossible. Logic. How helpless it is sometimes against the twist of fate. Mainstone got up, opened the door, went out into the corridor. His steps faded away. He got his tea, held the hot cup between his palms, maybe exchanged 2 words with a colleague standing up. And right at that time, exactly within those 5 minutes, the universe stepped in with that unique sense of humour. In the laboratory, in that silent room, that incredibly thin neck of the pitch went snap. The drop floated in the air and fell plop. When Mainstone returned, the teacup in his hand almost fell to the ground. Inside the bell jar, the 7th drop lay proudly on top of the others. Its shape hadn't even distorted yet. It was that fresh, that new, just 5 minutes. Wait 9 years, wait 3,285 days, and miss that moment during just a 5-minute bio break. Mainstone slumped into the chair at that moment. Did he laugh? Did he cry? Or did he just take a deep breath? Probably he just fell silent, and in that silence accepted a great lesson. Life is what happens to us while we make other plans. This event transformed the pitch drop experiment from being just a physics experiment into a philosophical fable. This was the victory of the unobservable. As if the pitch had a consciousness, as if it said, "I want privacy," like the moment of birth and the moment of death. The moment of falling is also special. I won't show you this, John. This belongs only to me and gravity. That missed moment in 1988 went down in records as one of the saddest but most instructive moments in the history of science. For Mainstone, this was not a defeat, actually. This was a bowing down before the greatness of nature. That tea he drank that day was probably the most bitter tea of his life, but at the same time, an elixir teaching him that patience has no end, because the pitch was still there, and preparations for the 8th drop, before that tea even cooled down, had already begun. At the molecular level, "We continue," said the pitch, silently. "If your tea is finished, I continue to flow." And time in that laboratory, in the shadow of missed moments, by slowing down even more, deepening even more, continued to flow. The next appointment, the year 2000, the millennium. And this time, humanity was not alone. Technology would come to help. But would technology be able to defeat the pitch's shyness? Now, let's leave Professor Mainstone and his cooling tea in the world outside the laboratory. Let's step out of the human scale, out of that world of meters and minutes. Squint your eyes, squint even more. Imagine approaching that shiny black surface of the pitch. We are descending to a size smaller even than the pores on your skin. We are smaller than a dust mote now, smaller than a virus, and we enter inside that black wall. Welcome. This is the inner world of pitch, the ocean of hydrocarbons. The first thing you feel is the crowd. This substance that looks stagnant from the outside is incredibly cramped inside. A chaotic and intimate environment. Space here is almost non-existent. Around you, there are chains extending endlessly, formed of carbon and hydrogen atoms, very long, molecular threads, coiling like snakes. These threads are not lined up neatly, side by side. Think of a plate of spaghetti, but let these spaghettis be kilometers long and all tangled in a knot. Here is the reason. Pitch behaves like a solid. Entanglement. Imagine you are a molecule Gravity calls you from below. You hear that irresistible voice. Come down, relax, let yourself go. You want to move. You want to slide downwards. But you can't, because your right arm is tangled in another chain. Your left leg is caught in another. 3 different molecules are wrapped around your waist. When you try to move, you have to drag millions of your neighbors with you. And here, those invisible, those weak but numerically strong forces come into play. Van der Waals forces. These forces are the electromagnetic attraction of molecules to each other. They are very weak, not as strong as a chemical bond, but when they act from billions of points, they turn into the world's strongest glue. Molecules whisper to each other, "Don't go, stay with me, hold on to me." This is the universe's greatest act of hugging. Pitch is actually the story of molecules that don't want to let go of each other. However, movement is not impossible. It is just very, very difficult. Time here means vibration. Heat gives music to this dark ocean. Every atom vibrates slightly where it is, dances, swings, left and right. Thanks to these vibrations, sometimes, very rarely, an opportunity window opens. Let's say the neighbor chain next to you. Stretch to the right for a moment with the effect of heat. That invisible hand holding you loosened for a microsecond. That very moment, you use that 1 in a billion chance and slide a nanometer downwards. You succeeded, but immediately after, another chain catches you. You lock again. You wait again. You vibrate again. When will the next opportunity come? Maybe a second later. Maybe an hour later. Here is the flow of pitch. It is the sum of these billions of tiny moments of liberation. That smooth drop shape you see at the tip of the funnel is actually the outwardly projected piece of that massive struggle inside. Trillions of molecules, that pushing and shoving, that war of hugging and letting go. Inside is chaos and struggle. Outside is just a silent glide. Just like a sleeping human. Looking from the outside, you see a motionless body lying down. But inside, the heart beats. Blood flows. Neurons fire. Dreams are seen. There is great activity. The pitch isn't sleeping. The pitch, at the molecular level, is dreaming a very intense dream. And this dream has only one goal: to reach down. Why do we fall? Why doesn't the pitch stay suspended in that funnel forever? Why do those molecules, despite holding on so tight, eventually give up and flow down? The answer to this is hidden in the universe's saddest but most peaceful law, thermodynamics, and its lead actor, entropy. Listen to this. not as a physics lesson, but as a lullaby. The universe does not like energy gathered in one point, a stone standing high, a stretched spring, the pitch at the top of the funnel. These are all tense, full of energy. Their potential is high. The universe wants to relax. The ultimate goal of the universe is maximum entropy. That is, the state where energy is spread out. Everything is balanced. Movement stops. Heat is equalized. That great state of rest. The pitch, standing at the top of the funnel, is a source of unrest for the universe. Gravity is a lullaby. The universe sings to the pitch. Aren't you tired of standing there? You are so high, so tense. Let yourself go. Come down. The ground is comfortable. The ground is low energy. The ground is balanced. The flow of pitch is the desire to attain this peace. That endless struggle of molecules, that effort to break van der Waals bonds, is actually to overcome an energy hill. This is called activation energy. There is a hill the pitch must cross. It must spend energy to flow. But when it crosses that hill, the reward is great. A lower energy level, a deeper sleep. Every time a drop falls, the universe relaxes a little more. The potential energy at the top of the funnel turns into kinetic energy while the drop falls, and when it hits the ground, into a tiny amount of heat energy and dissipates. Energy becomes free. That is why the flow of pitch is not a sad event. This is a homecoming story. The transition of matter from a forced form to a natural form. Aren't we humans like this too? We stand all day, spend energy, resist gravity. Our muscles tense, our mind tenses, our potential energy increases. And when evening comes, we lie in bed. Think of that moment. That first moment. You put your head on the pillow. That moment, your muscles surrender to gravity. That moment, your bones sink into the bed. That is the moment. You are like the pitch, too. You surrender to entropy. You spread your energy. You reach equilibrium. Sleep is the drop moment of the day. Sleep is our own plop sound. The pitch drop experiment is actually a simulation of the universe's sleep, lasting not 24 hours, but billions of years. Right now. That drop in the laboratory, that new mass accumulated after the 9th drop, is listening to gravity's lullaby. Heat says, move. Gravity says, come to me. Molecules say, sleep a little more. And amidst this triple conversation, time slowly melts. Ahead of us is the year 2000, a new millennium. Computers, internet, digital cameras. Humanity will set new traps to catch time. We'll build digital eyes to watch the pitch. Will we be able to succeed? this time? Or will the universe perform that secret dance of entropy behind the curtain again? Towards the millennium age, to the age of digital surveillance and the modern state of waiting, let us flow slowly. When the pendulum of time struck the end of the 20th century, humanity was in a strange panic. Late 1999, the world was preparing for a digital doomsday scenario called Y2K. Computers' dates would reset, banks would crash, planes would fall, electricity would be cut. Humanity feared becoming a prisoner of the speed and technology it created. Everyone was locked onto their watches, computer screens, countdown timers. But in that small room in Brisbane, the pitch drop was exempt from this fear. It had no operating system. Its software didn't need updating. Its only code was gravity, and this code had been working without error since the beginning of the universe. The millennium came. Lights didn't go out. Planes didn't fall. But a new era began for the pitch experiment. The age of surveillance. Professor Mainstone no longer needed to keep watch alone. Technology had planted a digital eye called a webcam in front of the bell jar. This camera did not resemble today's 4K resolution sharp cameras. It gave a low resolution, pixelated, grainy image. But the important thing was this eye never blinked, did not get tired, did not take tea breaks. And this image was spreading to the four corners of the world over that giant neural network called the Internet. The year 2000, the 8th drop was about to fall. Year 2000, November. This time, everything was ready. The camera was recording. Mainstone was on alert. The world was watching. This time, said humanity, this time, we will catch that moment. We will trap that drop digitally. But the pitch, as if possessing a quantum-level sense of humour, or perhaps the guardian angels of the universe, respected the pitch's privacy. Right at that critical moment, at that second, the drop was about to break. A storm broke out in the region where the University of Queensland is located, or a technical malfunction occurred. Whatever the reason, electricity was cut. The camera turned off. The screen went black. Signal lost. And within those dark 20 minutes, the pitch dropped its 8th drop. When electricity came back, when the camera turned on again, thousands of people across the screen and Mainstone running to the lab faced the same scene. The drop had fallen. They had missed it again. Even technology, recording 24 hours, could not catch that brief, that secret moment of nature. This event grew the legend of the pitch drop. It was no longer just a physics experiment. It was the symbol of the unobservable. It was a rebellious hero standing against the modern world's desire to see everything, record everything. Those waiting at the internet years after 2000 changed the shape of waiting. People could now follow this experiment in their offices, in their homes, on the small screens, in their pockets. The Pitch Drop's live broadcast became the internet's most boring but hypnotic show. Why were they watching? Nothing was happening on the screen. A black funnel, a grey background, and a drop that didn't move. But people watched. A university student opened it in the background while studying. As long as it stands there, they said, I can study too. An insomniac man found peace, looking at that blackness at midnight. This was the ancestor of the slow TV concept. Inside the internet, flowing fast, with constant notifications coming, constantly shouting, click, like, share. The Pitch Drop page was like a digital temple. There was no time there was no rush there was only the sweet weight of waiting. The year 2014. Years passed quickly again. By 2014, the 9th drop was now pushing the limits. But this time, there was a problem. The previous 8 drops had accumulated in the beaker below. They had formed a black mound. This mound had risen, approached the tip of the funnel. The 9th drop elongated and elongated and couldn't fall because there was no room left to fall. In April 2014, the tip of the drop touched the pitch pile below. This was not a fall, this was a reunion. The drop didn't break. It formed a black, thick column between the funnel above and the pile below. They locked onto each other. This situation was spoiling the nature of the experiment. To measure the flow of pitch, the drop needed to be free. The experiment's new guardian, Professor Andrew White, had to make a difficult decision. The bell jar must be opened, he said. The beaker below must be changed so the drop can break. This was a risky surgery. The bell jar, closed for 87 years, would be opened. Date: April 24th, 2014. Professor White lifted the bell jar at that moment. At that delicate moment, was it the air current created by the jar, or the table shaking slightly? Unknown. That drop, in the form of a column, snapped. And yes, the camera was recording, eyes were there, video was taken. But was this a natural fall, or a hastened end by human intervention? There were debates, but the result didn't change. The drop had fallen, and for the first time, somehow, it was recorded. However, the pitch had said the last word. Again, you couldn't catch me falling in my natural state, in my own loneliness. Either you cut the electricity or you had to intervene. The mystery of the pitch had not been fully solved, and this made the story even more beautiful. Now, let's get out of the laboratory, out of that small glass bell jar. Let's take that slow seeing ability the pitch taught us and open the windows to look at the world. If we had the pitch's perception of time, how would we see the world? Dance of the continents. Feel the ground beneath your feet. Solid, right? Safe, unshakable. No. The continent you are standing on right now is floating on the ocean like a giant ship, and it is moving. How fast? Look at your fingernails. Can you see the growth speed of your fingernails? No, but after a week, you notice they grew. Here, continents move at this speed too, about 2 to 5 centimeters a year. The pitch drop is like a race car compared to continents. Continents are much slower. If we could speed up time, we would see the map of the Earth constantly changing. We would watch South America and Africa separating from each other like pieces of a puzzle. These two land pieces, once joined, are moving apart, taking the Atlantic Ocean between them. A sad separation story, lasting millions of years. Breath of the Himalayas. Or look at the mountains. The Himalayas, formed by the Indian plate crashing into Asia. And this collision hasn't ended. It still continues. Right now, while you breathe, Mount Everest is rising. Millimetrically, the mountain is being pushed towards the sky. The pitch is flow, is downwards. The mountain's flow is upwards. Both are fluid. Both do not stop. Only the Deborah number of the material we call rock is even higher than pitch. Stones flow too, under pressure, deep in the earth. Granite and marble curl like dough. When you look at geological layers, you see those wavy lines. They are frozen photos of the rock's flow, tears of caves. Let's go underground, into a deep cave, dark, damp, silent. Look at those pointed stones hanging from the ceiling, stalactites. Each one resembles a pitch drop, but they are made of water and minerals. A raindrop filters through the soil, dissolves limestone, comes to the cave ceiling, hangs there. Water evaporates. A microscopic lime ring remains behind. Then one more drop, and one more. 1 centimeter per century. Those massive columns you see are the result of a dripping experiment, lasting millions of years. The pitch experiment has lasted 100 years. The cave experiment, 100,000 years. In that silence in the cave, you can hear time turning into stone, drop by drop. The pitch drop is a small ambassador standing there to remind us of this great, this slow, this magnificent rhythm of nature. It tells us, don't rush, look. Mountains don't rush. Continents don't run. Caves don't panic. Why are you so hasty? Nature's clock does not count seconds. it counts ages. And we, while falling asleep tonight, can set our watch to nature's slow time. Let's lift our eyes from the ground and turn to the sky. Let's take the patience of the pitch and carry it among the stars. Space, infinite emptiness, and infinite slowness. In science fiction movies, spaceships switch to light speed. Stars become lines, and they arrive in another galaxy instantly. But real space is quieter and more patient than even the pitch drop. Voyager's solitude. Think of the Voyager spacecraft, launched in 1977, one of the fastest objects of humanity has made, traveling at 60,000 kilometers per hour, many times faster than a bullet. But the scale of space is so big that Voyager is as if not moving at all. The stars in its background do not change. The Sunday becomes a slowly shrinking dot. Do you know how long it will take to reach the nearest star? 70,000 years. The next drop of the pitch drop will fall in 10 years. Voyager will arrive at its next stop after a time as long as human history. Imagine the silence inside that metal box. No engine sound, no wind sound, no friction, only gliding. This is the purest form of movement, resistanceless, effortless, infinite waltz of galaxies. Let's look even further. Our galaxy is the Milky Way. It rotates too, just like a vortex, just like the pitch, flowing by turning inside the funnel. But it is so big that completing a full turn takes 250 million years. When dinosaurs lived, we were not where the galaxy is right now. We were on the exact opposite side of the galaxy. Our entire history, all our wars, loves, inventions, do not amount to even a second in the galaxy's rotation. Is this size frightening? No. This size is comforting, because this shows how unimportant our small troubles, those jobs we call urgent, those appointments we say we must catch, are on a universal scale. The pitch drop is a small model of the cosmos. That blackness inside the bell jar is the vacuum of space. The falling drop is like the birth or death of a star, and that long wait in between is the normal state of the universe. 99.9% of the universe is waiting. Emptiness, silence. Movement is the exception. Stillness is the rule. We humans are trying to break this rule by constantly moving, constantly making noise. But when night comes and we put our head on the pillow, we return to that ancient rule of the universe, to silence, to motionlessness, and to the void. Now, prepare to glide like Voyager, to flow like pitch, to turn like galaxies. Your body might be motionless in bed, but your atoms are spinning. The Earth is spinning. The solar system is going. You are part of a massive flow. You don't need to do anything. The current is already taking you. Just let go. Like Voyager, turn off the engines and glide. Now, back to the room. Let's return to that dimly lit laboratory. Keep that feeling of vastness you brought from cosmic journeys, from galaxies and continents in your mind, but lower your focus back to that small black glass bell jar. The pitch drop is not just a physical experiment. It is a silent guru, a sage standing behind glass, never speaking, but giving life's greatest lesson with its stance. The name of this lesson, Amor Fati, loving one's fate. Speed, sickness, and pitch's prescription. Modern man, that is us, is suffering from a chronic disease. Speed, sickness. We get stressed if an internet page doesn't open in 3 seconds. We get angry when the traffic light turns red. When the elevator doesn't come, we press the button again and again, as if that will speed it up. We get anxious when our message gets a blue tick, but no reply comes. We are in a constant state of catching up. But to where? The pitch drop is the antidote to this disease. When you look at it, that hasty voice inside you has to shut up, because you cannot negotiate with pitch. You cannot say, come on, to it. You cannot speed it up by poking it. There is only one thing you can do in front of it. Acceptance. Accepting what is, at the speed it is, in the form it is. Why does pitch not suffer? Because it does not resist. Yes, its viscosity is high, its molecules hold on, but ultimately it does not say no to gravity. It does not try to swim against the flow. It becomes the flow itself. Most of our pains are born from the war between what is and what we want it to be. This traffic shouldn't exist. This job should have finished sooner. He shouldn't have said that. To me, pitch doesn't say. I should have flowed faster, or doesn't whine. Why am I not water? It accepts the weight of being pitch, and with that weight moves slowly, gracefully. Tonight, while lying in your bed, borrow this philosophy of the pitch. Think of the problems in your life, the delays, the waits, and stop resisting them. Let the traffic be jammed. Let the answer come late. Let things progress slowly. You are inside the bell jar. You are safe, and everything is flowing exactly at the speed it needs to. The universe's timing is never wrong. It just sometimes doesn't match our watch. Falling. People are afraid of falling. Failing. losing status, crashing to the ground. But for pitch, falling is an existential completion. When the drop breaks from the tip of the funnel, it doesn't panic saying, "Oh no, I'm falling." That moment is its moment of liberation. That moment is its moment of embracing gravity. That is the heart of the universe. You too are about to fall into sleep right now. Release your consciousness. Let go of control. Just like that black drop, trust the void. There is a ground below to hold you. There always is. On the timeline, let's come to today and a little to tomorrow. Right now, while you read these lines, inside that bell jar at the University of Queensland, the 10th drop is forming. Years have passed since the 9th drop fell in 2014. We are in the mid-2020s right now. The pitch has started to take that familiar pear shape again, accumulating at the tip of the funnel. Gravity is pulling it. When will it fall? Calculations show that the 10th drop will fall in the late 2020s, maybe 2028 or 2029. Maybe it will be left to 2030. Who knows? What will change in the world by then? Which governments will fall? Which technologies will become old? Where will you be? But one thing is certain, that drop will fall. And this time, cameras are much sharper, sensors are much more sensitive. Maybe artificial intelligence will be watching it, but the pitch might find a way to surprise us again. Maybe electricity cuts out again. Maybe the internet crashes. The pitch's mischievous spirit is still there. Centennial, fuel. And then, 11th drop, 12th drop, Professor Parnell was generous. When filling the funnel, there is still plenty of pitch inside the funnel. According to calculations, this experiment can continue for another 100 years. It will see. The 2100s. We probably won't. Our children will be old. Our grandchildren will be running the world. But that black drop will still continue to flow with the same rhythm, in the same corner. Let this thought not give you sadness. On the contrary, let this thought give you confidence. There are permanent things in the world. Even if we go, the story continues. There is continuity, there is connection. One day, in the year 2150, a student whose name hasn't been given yet will enter that lab, look at the dusty bell jar, and will look at that same substance Parnell poured in 1927, Mainstone missed, while drinking tea in 1988. Time is a bridge between people, and pitch is the strongest rope of this bridge. End of the experiment. One day, maybe in the mid-22nd century, the last piece of pitch in the funnel will flow too. The funnel will empty, The glass will become transparent, and the experiment will end. That moment will be like the last note of a long symphony, the sound of silence. But until then, we have lots of time. There are many more drops to fall, many more dreams to be lived. Now, the history of pitch is over. Its science is over. Its future is over. Only the present remains, and you remain. Your room is dark. You are in your bed. You are in a place as silent as the pitch's laboratory. Now, it is time to turn your body into that black, dense, fluid substance. Body scan. Transformation into pitch. Focus on your toes. Feel them. They are no longer bone and muscle. They are black, dense, warm pitch. They are getting heavy. They are sinking into the bed. There is the weight of molten rock on them. This weight is coming up to your ankles, spreading to your legs. Your knees are dissolving. Solidity is going. Your legs are integrating with the bed sheets, just like the pitch integrating with the container. Heavy, warm, motionless. Your hips and waist, those regions carrying the burden of the day, now they relax. The viscosity of pitch wraps your body. Your spine, that hard pole, now softens, lays on the bed like a rope. Every vertebra surrenders to gravity. Your stomach, you breathe in and out. With every breath in, your chest rises slightly. With every breath out, you sink down like pitch. Down, further down, deep. Your shoulders, those tense shoulders, you pulled up to your ears. Let them go. Let them fall. Let them flow into the bed. Your arms, your hands, your fingers are standing by your side like lifeless, heavy masses. Even if you wanted to lift them, which you don't, they would feel tons heavy because they are pitch now. They flowed and stopped. Your neck, that bridge carrying your head, relaxes. Your head sinks into the pillow. The pillow takes the shape of your head, or your head takes the shape of the pillow. Boundaries disappear. Your face, the lines on your forehead, smooth out like a smooth black glass. Your eyelids, tons heavy, they closed and locked. Van der Waals forces glued them together. Opening is very hard and unnecessary. Closing of the mind. Now we are inside your mind. Thoughts, they are slowing down too. Those fast thoughts during the day, ones like bee buzzing, now turn into honey, then turn into pitch. A thought comes. What will I do tomorrow? But this thought is so heavy, moves so slowly, that it freezes before completion, stays where it is, becomes unimportant. Another thought, I forgot this. Very slow, can't flow, stops, silence, swallows it. Your mind is now Professor Parnell's laboratory. We are back in the year 1927. Dark, dusty, silent, peaceful. No one is there. No phone, no sound, no light. Only that bell jar standing in the middle. And inside is you. You are that drop. You are at the tip of the funnel. You are ready. Below awaits you. The soft, velvet darkness of sleep calls you. You are safe. Time stopped. The world stopped. Only gravity exists, hugging you, rocking you, loving you. In a moment, very soon, that last bond will break too. That thin thread between consciousness and wakefulness is thinning, just like in 1938, just like in 1947. You are ready. Let yourself go. Take a deep breath, like the breath of the pitch, slow, and exhale. You are heavy. You are black. You are infinite. You are falling slowly, softly into dreams. Plop. Silence, darkness, peace. Good night.